Hi there. So our project is SAR ship detection using deformable data. This project is inspired by a research paper on SAR ship detection using deformable data. So they proposed a model called deformable data, which is a detection transformer with backbone feature extraction. So the aim of this project or the research paper is automated ship detection using synthetic aperture radar images using advanced deep learning techniques. So the dataset they used is SSDT dataset, that is SAR ship detection dataset, which has over 1,000 images and 3,000 ship annotations. The paper proposes an MAP metric of 0.682 on this dataset. So this is the workflow of the model. So initially we start to train the model. We let it go into the data processing layer where we try to map it to the annotations and dynamic padding, and then we'll try to send it to the actual deformable data model where ResNet model deformable it has deformable model and ResNet model where feature extraction happens, and then training also happens. After training, the model is saved as model.savetensors or config.json so that we can use that model again for the fast API inference. And this is the dataset description. The dataset has four subfolders called train, test ensure, test offshore, and test. So it also has annotation files as JSON. So this is a description of the dataset, and it's converted into COCO format, which is very obvious for object detection models. This is the main architecture of the model, which is deformable data model architecture, which primarily implements something called as deformable attention module, which is instead of attending to all the pixels for a single pixels attention score, like in DETR, that unimproved version of deformable data, where deformable data is the improved version of data, which uses standard self-attention model. But deformable data uses something called as deformable attention, where instead of attending to all the pixels for a single pixel value, it only attends to some important pixel sampling pixel values and to calculate the attention score. And it has three main parts: CNN network, that is backbone network, encoder and decoder. CNN does something called feature map extraction. The encoder does something called self attention, deformable self attention, and the decoder does something called as multi-scale deformable cross attention, where we also pass the object query so that it can draw the bounding boxes and predict class levels. So this is the training. How this is how training is done to the model. So, so these are the test metrics of the model. So then next, this is a model training where we stopped. There is we've trained the model on 50 epochs and early stopping at 30th epoch. And these are the results of this model. And I'll show you. So I'll upload this. This image shows that how the model is working. This is our actual image, and it is trying to predict the ship at which position the ship is and how much confident it is about the ship and how much processing time it takes and how many objects are detected. That's all. That's all about our model and our project. Thank you.